Okay, this is the warm-up. If you look at the problem, it's similar to problems you had in the last packet. Remember, with these type problems, you are looking both for the formula because you're going to need to plug in the x value plus h into it, and then also the x value by itself. So in addition to the formula, you're looking for that a value in the formula, which is always the x that's provided. The reason we are reviewing this is today's lesson is to find a derivative of a function. We are not looking for a number answer. We're looking for a formula or function answer when we are given an equation or a graph. We're going to skip over table of values. So when we end up with our answer, the answer is going to still have x in it. The answer will not be a number. It will not have h in it. It will just have a formula, a normal equation or function with x. So if you look over here, you can see that, first of all, we're plugging in 1 because x is 1, so that's our a value from the formula. The answer when it's plugged into the equation given is -2. And then not only do we need to plug in 1, we need to plug in 1 plus h everywhere I have an x. So if I have x squared, I must square 1 plus h. If I have 3 times x, it has to be -3 times 1 plus h. And then the result is -2 minus h plus h squared. All of this goes into the formula here. Remember, we simplify the numerator. We should end up with only h's so that we are able to divide both terms by h, allowing us to get rid of the denominator, so I'm not dividing by 0 anymore, and the answer to this problem is -1. Now, this is not what we're doing today. Today, our answers will have x in it, but the methodology is the same. So we're skipping over number 1 on page 13, and we're moving down to number 2. Notice the formula has changed a little bit. It's still the derivative equals the limit definition, but now we are not plugging in the given x value, because if you look really carefully, there is no x value given. It's just the equation. So what this new formula is telling you is to plug in x plus h everywhere you have an x to get the first part of the denominator, and then simply to subtract f of x. F of x is 2x squared plus x. So after you plug in x plus h into the given equation, you are simply subtracting that given equation and making sure you distribute the negative sign. So when I go to the next page, oh, it's not there. I thought the answer was there. All right, let me write it out for you. Okay, so I need 2 things. I need f of x, which was given to you as 2x squared plus x. That's going here. And I also need f of x plus h. That never changes. The only thing that changes is your formula that it gets plugged into. You do not have to look for an x value. You're always plugging in x plus h. So it becomes 2 times x plus h squared plus, everywhere I have an x, I'm putting x plus h. I'm going to simplify this. Remember, you want to use your PEMDAS rules, so you want to do x plus h times x plus h before you multiply by 2. That's x squared plus 2xh plus h squared. All of that is going to be multiplied by 2, and at the end you're going to add another x plus h. Distributing the 2 to all 3 terms, 2x squared plus 4xh h plus 2h squared plus x plus h. Combining like terms. Actually, I don't see anything that can be combined. This has x squared, this has xh, this has h squared, and this has x and h. So none of these terms can be combined. So I'm going to rewrite the formula. The derivative is the limit as x approaches 0 of f of x plus h minus f of x, that's the given equation, over h. So what I have here is the f of x plus h. Oh, I have to write limit. Limit x approaches 0. I'm sorry, h approaches 0 of 2x squared plus 4xh plus 2h squared plus x plus h. And now go back to your original formula, 2x squared plus x. That's what you're subtracting, and you must distribute this negative. The numerator looks very complicated, but you will see that a lot of things are going to cancel out. 2x squared minus 2x squared is 0. X minus x is 0. So the only thing I'm left in the numerator with is 4xh plus 2h squared plus h over h. Now, since every single term has an h in it, all of these h's can be canceled except for the h that's squared. So what I'm left with is limit as h approaches 0 of 4x plus 2, that's a 4 there, 2h plus 1 over h. Now notice, I'm sorry, not over h anymore. I divided that out. Notice now that I don't have an h in the denominator, I can plug in the 0. So it becomes 4x plus 2 times 0 plus 1. 2 times 0 is 0. So your final answer for this one is the derivative formula is 4x plus 1. Next problem. For b, we're going to do it the same way. Notice in the formula, I'm subtracting f of x. They give me f of x. There's nothing to plug in here. There is no x value. But notice the arrows that are drawn to remind you to distribute that negative. So our first thing to do is to plug in x plus h into this given formula. Everywhere I have an x, I'm putting x plus h. I'm going to FOIL x plus h times x plus h before I multiply by 3. Once I have the trinomial by FOIL, then I'm going to distribute the 3. I'm going to subtract the negative 2 times x plus h, making it negative 2x minus 2h plus 4. And then just like before, keep in mind, it will not simplify. Every term will remain individual. You will not, that says simplify. You will not simplify. So going back to the formula, it's f of x plus h. All of this goes here. And then we had to distribute the negative, so positive 3x squared became negative 3x squared. Negative 2x became positive 2x, and positive 4 became negative 4. Notice there's always going to be the terms that cancel out. 3x squared minus 3x squared is 0. 2x minus 2x is 0. 4 minus 4 is 0. So the only thing left in the numerator is the things I didn't cancel out. That is 6xh and 3h squared minus 2h. Remember, according to the limit formula, we are dividing each term by h. My new numerator is 6x plus 3h minus 2. Now I can plug in the 0, so it becomes 6x plus 3 times 0 minus 2. 3 times 0 is 0, so my final answer, the derivative formula, is 6x minus 2. Last problem. What does the derivative tell us graphically? The derivative gives us information about the function. And remember that the derivative is nothing more than the slope. If we're doing things graphically, then basically we're looking at the slope at every point. And obviously, we're not going to give you problems that have hard or different slopes for every different point or tangent. So the rule says that when your slope or derivative is positive, then that tells you that the original function is increasing. When my derivative or slope is negative, that tells me the original function is decreasing. When I get an answer of 0 for my derivative or slope, that tells me that I have found on the original function either a maximum or minimum. There is a constant over that interval, and a constant can also be a horizontal line or tangent. So I'm looking for max, mins, or horizontal original functions when my derivative or slope is 0. So when I look at these graphs, the slope at every single point on this original function f is 0. So the derivative at every single point is 0. So how do I draw that? I'm going to draw a horizontal line at y equals 0. For the second graph, I can see that it's rise over run. It's going to be up 2 over 1, up 2 over 1. So the slope is 2 at every point. So that means I'm going to draw a horizontal line of the derivative at y equals 2. Now you might recognize this function and this function for things we've done previously. Notice on the left, the slope is -1 at every point. And then we learned earlier that on the previous packet that hard corners do not have slopes or derivatives. That's why we have open circles here at x equals 0. Once we get past 0 on the right side of the function, all of the slopes are +1. So when I go to draw the derivative, I'm doing y equals 1 for the right side of the absolute value, and -1 because that's the slope on the left side. I hope this video helps you. I hope to see you soon.